We are solving two simple questions in semiconductor devices, both appeared in the NEET examination. The first question is, which one of the following represents the forward bias in a diode, right? I mean a PN junction diode. First of all, what do you mean by a PN junction diode is, semiconducting material is taken. From one side it is doped with p-type trivalent, from another side it is doped with a pentavalent, so that it becomes PN and the junction becomes a PN junction diode. A region is generated in this between called something like barrier potential, which opposes the flow of the current. So to overcome that, we shall connect a battery in forward bias. What do you mean by a forward bias is, from positive plate of the battery it is connected to p-type, from the negative plate of the battery it is connected to n-type. So here positive charges move and push this p-type materials forward, and same from here negative charges moves and push these negative charges forward. Thus the barrier potential reduces or it is overcome. Hence there is a flow of current. So for that to happen, positive plate of the battery has to be connected to p-type, and or in the other way, voltage applied to the p-type shall be greater than voltage applied to the n-type of the PN junction diode, so that it will be able to flow from P to N at the junction. So look at the options. This is 3 volts and 5 volts. We know 3 volts is less than 5 volts. So it's a reverse bias. Look at this. Minus 2 volts and plus 2 volts. Minus 2 volts is less than that of plus 2 volts. So it is also reverse bias. Right? Let's have a look at the next question. Minus 4 volts and minus 3 volts. You know, minus 4 volts is less than minus 3 volts because it's negative voltage. So it's a reverse bias. Here, first option, 0 volts and minus 2 volts. 0 volts is greater than minus 2 volts. Sorry, there is a flickering over the screen. Thus what we can say is, it is in a forward bias. So the diode that is in forward bias is this. This is in forward bias. That's a simple question, right? Let's have a look at the next question. What is the next question is? Consider the junction diode as ideal. What do you mean by ideal diode is? Resistance in forward bias across the diode is 0. Diode is not offering any opposition to the flow of the current. What's the value of the current passing through AB? But look at the voltage. This is plus 4 volt and minus 6 volts. It's very clear that plus 4 volt connected to p-type is much greater than that of the 6 volts. Thus, what we can say, like to the previous problem, PN junction diode is in forward bias. As it is in forward bias, current will flow. How much current will flow? We can find out using a formula V equal to IR. V means delta V between P and N. Plus 4 to minus 6 is 10 volts. Be careful. 4 to 0 is 4 volts. 0 to minus 6 is another 6 volts. Altogether 10 volts. I have to find out. Resistance is given like 1 kilo ohms. That is 1000 ohms. So the current in that is 10 by 1000. That is 1 by 100. That is 10 power minus 2 amperes. Option A is the correct answer to solve that problem, for that problem, right? That's it. Simple questions, simple answers. Thank you for watching.